Good afternoon, everyone. I welcome you back to my YouTube channel. Presenting before this wonderful tutorial is the mentor Hambi Kliman. And of course, if you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much. All right, so we now begin our session on interval notation. We've been asked to find this particular set operations, and if you've got a question, make sure that you inbox me on the WhatsApp line projected on the screen. Okay, so let's start. So the first thing that we're going to do, we've been told that let A be that particular set, B be that set, C that set. Then we find the operations D is equal to A intersection B complement. Then we find where C and D are intersecting. So the first thing to do is to write those particular sets. So let's try to write set A. Set A, we have been told that it's a set where X is a member of all real numbers with 0 included and 2 included. Then we've been told that set B is a set of all is a set where X is a member of all real numbers with 1 included and 3 included. Then C, we've been told that it's a set of all, well, it's a set where X is a member of all real numbers with, sorry. Okay, so sorry, 1 is not inclusive. 1 is not inclusive. It's exclusive. It's excluded. Okay, because we don't have the, we just have a greater, a less than. Then at C, we know that 0 is included. 1 is also going to be included. We can plot that on the real line. So if we plot that on the real line, we're going to have something like this. Okay, we're going to have a 0. And then we're going to have a 1. Then we're going to have a 2. Then we're going to have a 3. Okay. And then we are going to plot the first one. So the first one, we can use a different color. So the first one is going to be coming from 0 to be shaded up to 2. We can name it as A. The second one will be coming from 1, where there is an open circle there, up to 3. With a closed circle there, we can name it B. Then C is coming from 0 up to 1. So C is this set from 0 up to 1. Okay, so this is going to be C. Then they're saying, they're saying set D is the same as this set. Okay, set D is the same as that set. So we find where we find A intersection B complement. So first of all, we find where A and B are intersecting. They are intersecting here. Okay, this is where the two are intersecting. Then, since 1 was part of set A but it's not part of set B, so we're going to we're going to close the circle here and take it on the other end. Okay, and then since 2 was part of set A and it's also part of set B, we are going to open the circle here and take it on the other end. So that is going to become our A intersection B complement. Okay, even this guy is going to be A intersection B complement. So what is that set? So A intersection B complement is a set which is coming from 0 included all the way to 1 inclusive. Then since there's an open circle at 2 in the complement, so it won't be included, then of course 2 is going to be inclusive. Okay, so 3 is going to be inclusive because 3 is the largest number on my right. Now we have been taught that this same set that we have found here is the same as set D. So set D is also going to be this set. The second question is saying we find where C and D are intersecting. C and D are intersecting. So we are going to plot that set, this particular set here. Okay, let's plot that set. Let me just grab my board. Let's plot where set C and D are intersecting. Okay, so they're saying we find where C and D are intersecting. Let's plot set C. So set C is this set. We know it's here already. Then we can plot this set D. So set D, if we plot it, it's coming from, it's coming from 0. So 0 inclusive, so I'm going to shade there, close circle. Even here, it's going to be a closed circle. And then at 2, it's going to be an open circle. And then at 3, it's going to be a closed circle. So this is how you plot set D. The entire of this is set D. Now we found where they're intersecting with C. They're intersecting at this point. Now, since we have 0 is part of set D, but it's not part of C, so it won't be included. And since 1 is part of set D and is part of set C, to be included. So to find this guy here, C intersection D is going to equal to 0, 1 included. That is how you find the first question. The second question, they are saying, for each of the following sets, state whether it is finity or infinity, and in each case, justify your answer. Okay, so for the first one, they are saying you've got 0, 1 intersecting with all real numbers. All real numbers, trust me, these elements are also in Arab, because real numbers includes all numbers, every number that you can think of. So if you intersect real numbers with this set, what you are going to get is this set. But this is a countable set, henceforth it is finity. We go to B. B saying x is a member of all real numbers where x to the power 2 less than or equal to 4. Okay, so it says B is a set where x is a member of all real numbers, and this is going to be x to the power 2 less than 4. So the first thing you're going to do is to get that function, work out the function, then find the root of this function. If you find the root, you're going to get x, notice that what you're going to get is x less than -2 or +2, which can also be written as -2 then 2. This is interval notation. There are certain numbers in between -2 and 2 that you cannot count. You can't count them. Henceforth, this is an infinity set. We go to C. Okay, so C, we have been told we have that interval there, 0, 1. Then they're saying intersecting with 4, 3, then 3, 2. Notice that if you divide 4 by 3, you're going to get a number that is going to be 1 point, a certain number, greater than 1. If you divide 3 by 2, you are going to get a 1-point number. That is 2 greater than 1. So all the numbers in here are greater than the numbers in here. So if you want to find the intersection, you discover that they won't intersect at any point. So this is an empty set, and we know that the empty set is a finite set. That is correct. Okay, that is how you find for this particular question. The third question is saying some sets listed below are equal to other sets on the list. Which ones? Okay, so the first one that we have been given is, they're saying, okay, let's name industry. The first one is this set. Okay. So this one is very simple actually, just plot it. So you just need to plot it. You find the intersection, you've got a 1 there, a 2, a 3. So the first one you plot it, it's 1 inclusive, 2 inclusive. The second one, it's 2 exclusive, then up to 3, 3 exclusive also. So now, they're intersecting here, but 2 is part of this guy, 2 is not part of this guy. Henceforth, this particular set is the empty set. There's nothing intersecting there. We go to the second one. The second one is saying so we're going to plot the real line, put a 1 there, a 2 there, a 3. The first one is a closed circle here and a closed circle there. The second one is a closed circle there and a closed circle there. The two are intersecting here. The third one they are saying, okay, the third one they are saying intersection. You don't even need to go any further. This guy, look at the brackets. Here we only have two numbers, 1 and 2. But this one is a range. But the only number which is common here is 2. That's the only number which is common there. It's going to be a 2. Okay? Then we can go to the fourth question. We can go to the fourth question. The fourth question is saying, okay, so of course you can plot this guy. So this is going to be 1, 2, 3. Okay, you've got a closed circle here, a closed circle there, and then you're going to have a closed circle here and a closed circle here. So they're intersecting. Where are they intersecting? These guys intersecting here. Okay, so meaning they're intersecting at 2 included, 3 included. So where the question was saying some sets listed below are equal to other sets on the list, which ones? So the only set that are equal is this guy here for set 2 and this guy here for set 3. So what would be my conclusion? So set B and set C are equal. Only set B and C are equal. If you found this video interesting and wonderful, consider subscribing, hitting the like button, don't forget to share to others. Thank you so much.